So far, we've seen how to solve algebraic expressions that have lots of operations. We learned about order of operations, and we've played around with lots of fractions and decimals. But sometimes you're not going to be given an algebraic expression when presented with a problem. Sometimes you're going to be given a whole bunch of words, and you're going to have to take those words and turn them into an algebraic expression that you will then solve. So how will we do that? Well, first you need to recognize how you can go from words, a verbal phrase, to an algebraic expression. So for example, you could have the sum of 6 and a number. In this case, a number is x, so you end up with 6 plus x. Let's go down a few. A number is increased by 7. So in this case, increased is the addition sign, and the number you're talking about is x. So x plus 7 is the same thing as a number increased by 7. Similarly, you can have lots of things with subtraction. And when you get to multiplication, the new word you're looking for is product. The product of 9 and a number, again, a number in this case is going to be x. 10 times a number, you could have n instead of x. You can have any label you want. A number multiplied by 3. Multiplied is going to be the same thing as product. Similarly, you can do just about the same thing with division. The only thing you have to watch out for is you have to make sure the right number is in the numerator, the top, and the denominator, the bottom. So again, that's numerator on top and denominator on the bottom. So the quotient of a number and 4 is going to be in the denominator, and n, this case a number n, is going to be in the numerator. 7 divided by a number, so 7 is divided by x right there. So let's write out these verbal expressions as algebraic expression. We're looking at 3 more than, so it means we're going to add 3 to something, the quantity 5 times a number n. So the quantity 5 times a number n, get blue here, it's going to be 5 times a number n, and you're making it 3 more than that, so it's going to be 5n plus 3. 2 less than, so you're going to subtract 2 from the sum, so addition, the sum of 6 and a number m. So the sum of 6 and a number m is going to be 6 plus m. A number x is decreased by the sum of a number x, so x is going to be decreased by. So in this case, decreased by is that minus sign, the sum of 10 and the square of a number y. The tricky part is you have to come up with the sum of 10 and a number and the square of a number y. So it's the sum of 10 and the square of a number y. You have to add them together inside parentheses there. It's careful. You have to be careful and read these slowly. So a number x is decreased by, so you have the minus sign, the sum, so the sum in this case is the addition sign of 10 and the square of a number y. So you're squaring y. When you're writing things out in words, you could either write a phrase or a sentence. They're going to look different. The sum of 6 and a number is just an expression. Note that this does not equal anything, it's just 6 and a number. The key difference here between phrases and sentences is going to be this word here is 12, or there's going to be some sort of verb. So the sum of 6 and a number is 12. In this case, the is correlates to equals. So in this case, this sentence translates to an equation. You can also have an inequality. 7 times a number, and that's right there, 7 times a number, is less than is the symbol right there, 50. So in that case, that sentence leads to an inequality. An inequality, it is not equal. What you're going to get good at is this process, where you're going to go from writing a verbal model to assigning labels, labeling variables, to writing an algebraic model, and then from there you are going to solve the algebraic model and then check your answer. The reason it's called modeling is because you're modeling a real-life expression. And remember, the expression can be an equation or an inequality, and what real life is can be open to debate, but in general it should be something that's applicable to something that you might see outside of the classroom. So here's one problem. You and 3 friends are having a dim sum lunch, and I highly recommend trying dim sum sometime if you haven't, at a Chinese restaurant that charges $2 per plate. You order lots of plates of wontons, egg rolls, and dumplings. The waiter gives you a bill for $25.50, which includes tax of $1.20. Use mental math to solve the equation for how many plates your group ordered. So let's actually come up with our written model first. So our goal here, is to find out how many plates our group ordered. How many plates our group ordered. So we don't know what that is, so let's just call that P. Whatever algebraic expression we come up with, we're going to use P for the number of plates the group ordered. We know that it's the cost per plate times the number of plates is going to be how much we spend on the food total. But we know that our bill also includes tax, and we know that the total bill comes to, well, that's total bill. And now what we can do is start filling in for what we know, either with labels or numbers. So again, here's one written model. There's different ways in which you can do this, but here's one. You know that the cost per plate times the number of plates is how much you spend on the food, and when you add in the tax, you end up with the total bill. Well, we know the cost per plate is $2. We don't know the number of plates, but we've decided that it's going to be P is the number of plates. We know that the tax is $1.20, and we know that the total bill is $25.20. So you might have done some of this work in your head. You subtract 120 from 25.20, but this is a way you can keep track of your mental math, which can get pretty complicated pretty quickly. So in this case, we now have 2P equals 25.20 minus 120. So 2P is going to be equal to 24. Divide both sides by 2 and you get 12. So your answer would be 12 plates. Does that make realistic sense? Let's check our answer. 12 plates seems pretty good for 3 people, I guess. And also let's check to see if it works. If you ordered 12 plates and they cost $2 each, you'd spend $24. And if the tax was $120, you'd add that in and you'd have $25.20. So our answer does check. And it also makes realistic sense, which is good. If we had finished with an answer like a billion or a negative plates, maybe that would be a good signal that something's wrong. Overall, our process is going to look like this. You're going to start with a verbal model, which is also another way of saying your written model. So you're going to write it out in words, and then you're going to assign labels. After that, you're going to end up with an algebraic model, which you will solve and then check. Even though it sometimes seems a little frustrating to do all these steps out for every single problem, it will save you a lot of hassle because it'll help you avoid making lots of mistakes. So again, verbal model, then labels, then algebraic model, solve, and then check. It's really important that you remember those steps. I hope you found this video helpful.